Hello y'all, welcome to lesson 5 where we're going to be talking about error analysis, and your learning target is I will be able to create an argument or critique the reasoning of others in solving algebraic equations. So we're going to be looking at 2 examples of students solving the same problem and looking for where their error is. Now when I am looking for errors, I always start with just solving it myself. So I'm going to start with example A. I would look at this and think, okay, my first step here, and I'm going to go ahead and just jump to this solve correctly spot. Let me put that equation in. Okay, so my first step is going to be the distributive property. I want to rewrite that. Okay, so I got my negative 2x minus 8 equals 16. Now I'm going to go back and look at their first step. So this student's first step was to subtract 4 from each side. And that was honestly their error. That was it. Because they saw, and this is one of the most common errors I see, but they saw this plus 4 right here, and they're like, well, let's get rid of that constant. Let's subtract 4. But the reason that that is an error is that that is not actually a positive 4 because it is a part of a group. So order of operations says that this actually means negative 2 groups of x plus 4. Therefore, instead of a positive 4 right there, we have a negative 8. So that's my mistake. I'm going to go on and just solve it correctly. So we would add 8 to each side instead of subtracting 4. Come up with negative 2x equals 24. Divide by negative 2. Divide by negative 2. And I got myself positive x equals negative 12, and I can do a check with that. Okay, so replace x with negative 12, and this now turns into negative 2 times negative 8 equals 16. And indeed, that turns into positive 16 equals positive 16, so I am correct. All right, so now let's actually do the analysis. We have our error highlighted. That error was subtracting 4, and we want to explain the error in words. And you could put this in your own words if you want, but I'm going to say that student A forgot that this positive 4 was a part of a term in which it's being multiplied by negative 2. So we can't work with it until that multiplication has happened. All right, let's work on student B. So since it's the same problem, we have the same solve correct and the same check, but this time this student's first step was to add 2 to each side. This is another really common error, is students see this hanging out outside and they forget that that means distributive property. They think it's a constant, but this is not a constant. That is actually a coefficient, or a multiplier, because it tells us how many groups of x plus 4 we have. So that's our highlighted error. Let me jot that down in words. Right, there's my sentence. Yours could be something different, but negative 2 is a multiplier, not a constant, so it can't be added to make 0. It represents negative 2 groups of x plus 4. You all are going to be asked to do error analysis on several equations and your journal problems, and some of them are going to first need to have some like terms combined. So I just wanted you to see a couple examples of that. So when there are several different terms that can be combined on one side of your equation, your first step is you want to go ahead and combine those. So we want to take negative 3x and negative 2x and combine them before we can do any solving, right? Get my T diagram all set up here. Negative 3x plus negative 2x is negative 5x plus 9 equals negative 6. And from there, we can just use our normal algebraic steps. We can subtract our 9. So then we have our negative 5x equals negative 15. And then divide by that coefficient, divide by negative 5, divide by negative 5. We come up with a positive x equals positive 3, and we can do our check. And I suggest doing a check with your original equation just in case you made a mistake in the combining like terms process. So I'm actually going to do my check with negative 3x plus 9 minus 2x. And now we can simplify. So negative 3 times 3 is negative 9 plus 9. Negative 2 times 3 is negative 6 equals negative 6. This is just a 0 pair. So we have left minus 6 equals negative 6. Whoops, not negative 0. And indeed, 0 minus 6 is just negative 6, which equals negative 6, and we're done. Please always do that last step. Don't just stop, even though you can do it intuitively. Do your last step. Okay, you try it. This is some practice with fractions. Go ahead and pause this, give it a shot, see how it comes out, come back and check your work. All right, there's my whole process. This was a 7-stepper. Go ahead and look through that, see if you got something different, and try to catch your error. And then I'm going to do a check. And there we have it. There's my check. Kind of a longer process because we got some fractions, but it's good practice for you guys. Okay, grab those journal problems, get going. Let me know how I can help you. Thank you all so much.